Hello there my friends, and welcome back to my channel. Now in this topical series for 2020, we are going to be looking at transformations questions taken from these papers. I hope you're going to learn a lot from this. We can get started. So here's question number 2. It goes, the graph of y is equal to function of x is transformed to the graph y is equal to 1 plus f of a half of x. Describe two single transformations which have been combined to give the resulting transformation. Okay, so right here, we've got our function y is equal to 1 plus f of a half of x. There are two transformations going on here. This one is a stretch. This represents a stretch. You need to know that all transformations represented by the function f of ax from a function of x represent a stretch parallel to the x-axis, and the stretch factor is 1 over a. So this is a piece of information that you need to know. And then we also have this part, the one, it represents a translation parallel to the y-axis. So that's a translation, because you need to know that the function f of x plus a, where a is a constant, represent a translation parallel to the y-axis. So 1 is being added to the function, so that means that it's a translation. So here's how you write down the solution. So you say the first transformation is a stretch parallel to the x-axis with the y-axis invariant, and then the stretch factor is 1 divided by a half, so that's 2. Then the second transformation you say is a translation in the direction of the y-axis by positive 1 unit. So in other words, the graph is going up by 1 unit. So that's the transformation here for number 2. So that's it for question number 2. Question number 4. So we have a graph here, and the question goes, the diagram shows the graph of y is equal to f of x, where f of x is equal to 3 over 2 cos 2x plus a half for 0 to pi. Those are the values of x. On A, state the range of f. Now we want the range of this function here, and it's a trig function. We know the original trig graph of y is equal to cos x, and we know that the range for the function cos x is within plus and minus 1. So y values between plus 1 and minus 1. So I think you can see that this graph here is simply a transformation of the graph of y is equal to cos x. And the transformation involves a stretch parallel to the y-axis, and a stretch here again parallel to the x-axis, and here it's a translation by half a unit going up. So the two transformations that will affect the range, which are the y values, is the stretch here and the translation. So how will the stretch affect the y values? The stretch has factor of 3 over 2, so 3 over 2, and we multiply or transform the maximum and minimum values of cos x, that's plus or minus 1. And the other transformation affecting the y values is the translation, since our graph will be going up by half a unit. So that will be plus a half. We actually have two things here. We have minus 3 over 2 plus a half, and we also have positive 3 over 2 plus a half. And minus 3 over 2 plus a half will give us minus 1, and 3 over 2 plus a half will give us 2. And therefore, these two values will become the range of the function f of x. So it will be from minus 1 to 2. So this here is our answer. This is the range of the function. Let's scroll down to part B. A function g is such that g of x is equal to f of x plus k, where k is a positive constant. The x-axis is a tangent to the curve y is equal to g of x. So in part B, state the value of k and hence describe fully the transformation that maps the curve y is equal to f of x onto y is equal to g of x. So we want to use the piece of information that we have right here. Now, the new function g of x is f of x plus k. And if we're adding a constant to f of x, this represents a translation going up by k units. And to help us understand better, they say the x-axis is a tangent to the curve. So the situation here will be like, this is the graph of y is equal to f of x. So when we now have the graph of g of x, which is f of x plus k, it means this graph is rising up by k units. So the graph of g should now come out to be like this. It has been translated up by k units, since k is a positive constant, until the graph of g, this is the graph of g of x, now touches the x-axis once. So the x-axis is now a tangent to this graph. So we know that the minimum point of this graph, from the range we got it to be minus 1. So by how many units should it be translated up so that the x-axis is a tangent? That should be 1 unit, where k is equal to 1. So k is just 1 unit. So to answer the question, state the value of k. So k is 1. And it says, and hence describe fully the transformation that maps the curve y is equal to f of x onto y is equal to g of x. So we're saying it's a translation by 1 unit in the positive y-axis. So that's the transformation. Let's go on to part C. On part C, it goes, state the equation of the curve, which is the reflection of y is equal to f of x in the x-axis, and give your answer in the form y is equal to a cos 2x plus b, where a and b are constants. Alright. Now, we have the graph y is equal to f of x, and f of x, according to the information given, is 3 over 2 cos 2x plus a half. So I'll write it here. So if we're talking of a reflection of y is equal to f of x in the x-axis, then the transformation is represented by y is equal to minus f of x. So that's minus f of x is minus of 3 over 2 cos 2x minus a half. So therefore, the reflected graph should simply be y is equal to minus 3 over 2 cos 2x minus a half. And that's the solution right here. Let's go to question number 9. Functions f and g are such that f of x is equal to 2 minus 3 sine x for 0 to pi, and g of x is equal to minus 2 of f of x for 0 to pi. So on A it says state the ranges of f and g. Now for the function f of x, you look at the function sine, and we know that for the graph y is equal to sine x, the range for y is plus and minus 1. So when we have now 2 minus 3 sine x, it means the range will now be 2 minus 3 of the range of sine 2x, which is plus and minus 1. So that's plus and minus 1. So we're going to have 2 minus 3 here, which is minus 1, and 2 plus 3 here, which is going to be 5. And therefore, the range of f comes out between minus 1 and 5. So that's the range of f. And this therefore means for g of x, since g of x is minus 2 of f of x, it means we're going to multiply the limits of the range of f times minus 2. So 5 becomes the lower limit when multiplied by minus 2, so that will be minus 10. And multiplying minus 2 times minus 1, we get 2. So the range will be from minus 10 to 2. So that's the answer here for the range of g of x. Let's go to the next part of the question. So the diagram shows the graph of y is equal to f of x. So on part B, it says, sketch on this diagram the graph of y is equal to g of x. Now we know that the function g of x, according to what we've been given, is minus 2 of f of x. So it's minus 2 of f of x. And we have the graph of f of x right here. Now this represents two transformations. The first one represented by the negative sign is a reflection in the x-axis. And the second transformation represented by the 2 is a stretch parallel to y by factor 2. So we are going to perform these two transformations. Okay, so first of all, the graph is going to be stretched by factor 2 parallel to the y-axis. So for me, the graph will come out like here, goes up, then down. The x coordinates are not affected, then down, then up, maybe like this. So this is how the graph of g of x should come out. So it's showing us two things. Number one, the fact that the graph of y is equal to f of x has been reflected. That's why it's now flipped upside down. But besides being flipped upside down, it's now it's also been stretched by factor 2. So that's why it's now looking a bit more stretched than it originally was. So this is more like the sketch that is required here. Let's go on to part B. The function h is such that h of x is equal to g of x plus pi for minus pi to 0. Describe fully a sequence of transformations that maps the curve y is equal to f of x onto h of x. Okay, so here we're starting with the original graph as f of x. F of x gave us the graph g of x, and now g of x is being transformed onto another graph, which is h of x. Now, from f of x to g of x, what was the transformations? We learned from the question that g of x is minus 2 of f of x. So we had g of x being equal to minus 2 of f of x. So we said this represents a reflection in the x-axis that's represented by the negative sign, and also followed by a stretch parallel to the y-axis by factor of 2. And then here, from g of x to h of x, we hear that h of x is g of x plus pi. Now the plus pi here is a constant inside the bracket, so we know that f of x plus a represents a translation parallel to the x-axis by a units in the negative x direction. So we can say that is a translation by how many units? Minus by pi units in the negative x direction. So these here are the 3 transformations for 3 marks, and that's the answer. In each of parts A, B, and C, the graph shown with solid lines has equation y is equal to f of x. The graph shown with broken lines is a transformation of y is equal to f of x. So on A they say, state in terms of f the equation of the graph shown with broken lines. Now you can notice that the graph with broken lines is a reflection of the bold graph, and the mirror line is the y-axis. So for a reflection in the y-axis, we would write the equation of the reflection as y is equal to f of minus x. And that's the answer here for part A. Then for part B, state in terms of f the equation of the graph shown with broken lines. Now if you look here, you can notice that the graph y is equal to f of x has been stretched to produce the graph with broken lines. And what is the stretch factor? Well, if you look at a point and its image, like if you look at this point, the y coordinate is 2 and its image here has the y coordinate 4, which means there's a factor of 2 here that is mapping object to image. So you can notice that that's what is happening. Even if you look at this point here and this point here, it's again a factor of 2. If we multiply the y coordinate by 2, we get the image. So the factor appears to be 2. You can also notice that the x values are not changing. So x value remains 1, x value here remains 2. So it means that the x-axis is invariant. So if it is a stretch by factor 2, we can write that as y is equal to 2 of f of x. And that's the answer right here. Then to part C, again it says, state in terms of f the equation of the graph shown with broken lines. So here we can see that the graph y is equal to f of x is being translated to the graph with broken lines. It's actually moving in a straight line but maintaining its original dimensions. So it shows that it's a combination of translations. So I'll try to move from this point to its image, which is here. In the x-axis, I'll move 1, 2, 3, 4. So that's minus 4 in the x-axis, and then I'll go down 1, 2, and 3, which is minus 3 in the y. So this is our translation vector. And how do we write that in terms of f? That would be y is equal to f of x plus 4. That's for the translation in the x direction. And that's minus 3. That's for the translation going down by 3 units in the negative y direction. So this becomes the equation of the graph in terms of f. Let us look at question number 4. In the diagram, the lower curve has equation y is equal to cos theta. The upper curve shows the result of applying a combination of transformations to y is equal to cos theta. Find in terms of a cosine function the equation of the upper curve. So we have right here the graph of y is equal to cos theta, and is being transformed onto the graph above it. Now, when we are considering transformation, there are two sets of transformations to be concerned about. The first set of transformation is the one that affects the vertical aspects of the graph. And here, if we have our original function y is equal to cos theta, which I want to write as y is equal to f of theta, then it has to be transformed in the vertical to a new graph y is equal to a of f theta plus b. A should represent a stretch parallel to the y-axis, and b should represent a translation in the positive y direction by b units. So in this case, the point, if you take a point like a point 1 here, you can see how it is being transformed to a corresponding point on the other graph, which is at 5. So we are saying the point y is equal to 1 is being transformed onto y is equal to 5, which therefore means that a of f of theta, which in this case is 1, plus b is giving us 5. So this translates to a plus b is equal to 5, where a and b are constants to be found. Again, you can see that another point that we can take, which is this point, which is the first lower peak of the graph of cos theta on minus 1, is being transformed onto the first lower peak of the other graph is here, which has a y value of 1. So we're again saying here the point y is equal to minus 1 is being transformed onto the point y is equal to 1, which means that a of the point f of theta minus 1 plus b is giving us a 1, and this is the equation minus a plus b is equal to 1. Now we now have two simultaneous equations which need to be solved, and I'll do this simply by adding equation 1 plus equation 2. If we add equation 1 plus equation 2, that's a plus minus a gives us 0, b plus b gives us 2b, and 5 plus 1 gives us 6. So this therefore means that b is equal to, dividing both sides by 2, b comes out as a 3. And again, we can also find, using any one of the equations, like equation 1, we can say, since a plus b is equal to 5, then that's a plus 3, which we got, is equal to 5. And this therefore translates to a being equal to 2 after subtracting 3 from both sides. So we now know what a is and what b is. So we're going to be using this a bit later. Let's now consider the horizontal aspects of the transformation. So for horizontal, we are mainly concerned about the region inside the bracket around theta. The set of transformations, I would want to represent them with constants C and D, like C theta plus D. So this will affect the horizontal aspects of the graph. So let's look at some X points that have been transformed. And let's start with this point here, which has an X coordinate of 0. So this point has been transformed onto this point here, which also has an X value of 0. So we're saying here the point 0 is being transformed onto point 0, which therefore means that C of 0 plus D is giving us 0. And this translates to D is 0. Again, let's look at another set of points. Another set of points can be the first lower peak of the graph of y is equal to cos theta should correspond to the first lower peak of the transformed graph, which is here on 2 pi. So this first lower peak of y is equal to cos theta is on pi. So pi is being transformed onto 2 pi. So let's have that as well. The value x is equal to pi is being transformed onto x is equal to 2 pi, which therefore means C of theta, which is pi, plus D is giving us 2 pi, which is pi C plus D is equal to 2 pi. But we know that D is 0, which therefore means that pi C is equal to 2 pi. And if we divide both sides by pi, we get C coming out as 2. So we now know what C is. So let us now write the transformations. So we have y is equal to a, in this case, is 2. So that's 2 of f of. And inside the bracket, we're going to be having C theta plus D. So we got C to be 2. But since the graph has been widened out, I'll write that factor as 1 over 2. So it's 1 over 2 theta, close bracket. And then it's plus b, and we got b to be 3. So it's plus 3. So eventually, in terms of cos, we write it as y is equal to 2 cos of half theta plus 3. So this becomes the final answer. Part D. The functions f, g, and h are defined for x is an element of Orion numbers by, and we have here f of x, g of x, and h of x. So on D, they say describe fully a sequence of transformations that maps the graph of y is equal to f of x to the graph of y is equal to g of x. So we're talking about f of x to g of x. So g of x is f of 2x plus 4. That's f of 2x plus 4. Now, when you have a constant inside the bracket here, multiplying x for the function f, it means we're talking about a stretch parallel to the x-axis, and the factor will be a half. And when you have a plus 4 here, this is mainly going to be a translation parallel to the y-axis of factor 4. So let's write that down. First transformation is a stretch of factor a half, and that's parallel to the x-axis. So that's the first transformation, and the second transformation is going to be a translation in the y direction by 4 units. So these are the two transformations for f of x being mapped onto y is equal to g of x. Then on part E, describe fully a sequence of transformations that maps the graph of y is equal to f of x onto y is equal to h of x. So here we've got f of x getting on to h of x. Now for 2 of f of x plus pi over 2 or half pi, let's write that down. 2 of f of x plus half pi. The two transformations happening here. The 2 on f means we are talking about a stretch parallel to the y-axis with vector 2, and the half pi here means we are talking about a translation parallel to the x-axis by minus half pi units. Okay, so let's write that down. We start number 1 inside the bracket, so that's a translation in the x direction by negative half pi units. And then we go outside then with the 2, so that's a stretch by a vector of 2 parallel to y-axis. And these are the two transformations right here. On question number 1, part A, express x squared plus 6x plus 5 in the form x plus a squared plus b, where a and b are constants. So here, all they want you to do is to perform completing the square. So what I'll do is I'll open up my bracket, then I put the square root of x squared, which is x, then it's plus half of the coefficient of x. The coefficient of x is 6, so half of that is 3. Then squared, then we subtract the 3 squared, then it's plus 5. So this eventually gave us x plus 3 squared, and this is minus 9 plus 5, which is minus 4. So this is what we get. Let's go to part B. On part B, they say the curve with the equation y is equal to x squared is transformed to the curve with the equation y is equal to x squared plus 6x plus 5. Describe fully the transformations involved. So here I'm going to say let f of x be equal to x squared, which therefore means that for the equation y is equal to x squared plus 6x plus 5, which we also expressed by completing the square, we got this to be x plus 3 squared minus 4. So this is the same as x plus 3 squared minus 4. So we can say that for x plus 3 squared minus 4, in function notation, we can write that as f of x plus 3 minus 4. So we now have the equation y is equal to x squared plus 6x plus 5 in function notation as f of x plus 3 minus 4. So now that we have it this way, so we can now say this part represents a translation by minus 3 units in the x direction. And the second transformation, represented by minus 4 here, is again a translation by minus 4 units in the negative y direction. So this is what we get. Let's scroll down to the next question.